A ratio is a comparison by division. Let's practice creating and simplifying equivalent ratios when using visual models, tables, and fractions. In a gumball machine, the ratio of green to yellow gumballs is 2 to 1. If there are 6 green gumballs, how many yellow gumballs are there? We can represent this 2 to 1 green to yellow gumball ratio using a picture. If we double the amount of green gumballs, we also have to double the amount of yellow gumballs. We now have 4 green gumballs and 2 yellow gumballs. If we add on another 2 to 1 ratio of green to yellow gumballs, we now have 6 green gumballs and 3 yellow gumballs. We now have 2 equivalent ratios. We know that 2 to 1 is an equivalent ratio to 6 to 3. The ratio of incorrect to correct answers Ashley got on a math quiz is 3 to 7. If she missed 9 questions, how many questions did she get right? Again, we can use equivalent ratios to determine the number of questions Ashley got correct. Let's use a table. In order to go from 3 questions missed in our ratio to 9 questions missed, the actual number of questions that Ashley missed on the quiz, we need to look for a multiplicative relationship. We know that if we multiply 3 times 3, that will get us to the number 9. When we multiply the number of questions missed by 3, we also have to multiply the number of questions correct by 3 in order to maintain the same ratio. 7 times 3 gets us to 21. We know that if Ashley missed 9 questions, in order to maintain that same ratio of 3 to 7 questions missed to correct, Ashley had to get 21 questions correct. In order to draw an accurate model of a skyscraper, an architect needs to draw the length and the height using the ratio 1 inch on paper to 1,000 feet in real life. If the height of the building is 2,100 feet, how many inches will the architect draw it on paper? Again, we can use a table to describe this relationship and determine the length of the building on paper. This time, we're going to look at a within relationship. This type of relationship looks a little bit different from what we did in the first example. We are going to look for a relationship between these two numbers using multiplication. I know that 1 times 1,000 gets me to 1,000. We can use the inverse of this relationship in order to find our missing number in the table. The inverse, or the opposite, of multiplication times 1,000 is to divide by 1,000. So we can divide our height in real life, 2,100 feet, by 1,000 to determine how many inches the paper model will be. When I divide 2,100 by 1,000, this gets us to 2.1 inches that the architect should draw on paper. In this situation, we have a ratio of 6 green candies for every 8 pink candies. Again, we can use a table. We have 6 green candies and 8 pink candies. We want to write an equivalent ratio that has a total of 42 candies. In order to do this, we have to look at the total number of candies in our original ratio. In our original ratio, we have 6 green candies plus 8 pink candies, which is a total of 14 candies. We want to go to a total of 42 candies. So we need to find the multiplicative relationship between 14 and 42. We know that if we multiply 14 by 3, we get 42. We can use this relationship to multiply by 3 to create our equivalent ratio of green and pink candies. Since we multiplied our total by 3, we also have to multiply each our green and our pink candies by 3. So when we multiply our green candies by 3, we get a new quantity of 18 green candies. When we multiply our pink candies by 3, we get a new quantity of 24 pink candies. Let's double check this and make sure that our new quantities have a total of 42. 18 plus 24 does give us a total of 42 candies. We use the within relationship here to create a new equivalent ratio. To find our other equivalent ratio, this time with a total of 7 candies, let's use a new table. In order to do this, again, we have to look at the total number of candies in our original ratio, which we already said was 14. This time, we want to go to a total of 7 candies. So we need to find the multiplicative relationship between 14 and 7. We know that if we divide 14 by 2, that'll get us to 7. So we can use this relationship to determine the new quantity of green and pink candies. When we divide 6 green candies by 2, this gets us to a new quantity of 3 green candies. When we divide our pink candies by 2, this gets us to a new quantity of 4 pink candies. Let's double check this again to make sure that our new quantities have a total of 7. 3 plus 4 does give us a total of 7. Again, we use this within relationship to create another equivalent ratio. We can create and simplify equivalent ratios using visual models, tables, and fractions. Ratios are a comparison of quantities by division.